with it. And I thought, oh, I could use that to make the starting material. So I did this reaction and formulated it, and I got like 25 grams of the dimethoxymethylthiobenzyl. So then I wrote and said, you know, we want to collaborate on publication. I've got this starting material. And of course, I could have done it all myself, but I wanted to publish with Sasha. So how about if I send you the aldehyde, you make the 2C compound, the amphetamine, and we'll publish it together. So we did publish it. It was sulfuranones and psychotomimetic amines in Journal of Pharmaceutical Sciences. 1976, maybe, something like that. So that was the first of the sulfur compounds. And then that led to a whole bunch of sulfur compounds because patents that maybe these psychedelics are active because the methoxys were demethylated. The orthomethoxy or 5-methoxy were demethylated. So he envisioned that maybe if you put a sulfur there, they wouldn't be demethylated. And maybe that would prove the theory that, you know, you had this demethylation. So they proposed a series of putting a sulfur in the 2 and 5 positions in addition to the 4 and seeing whether the compounds were still active. And I think the 5 sulfur, I think it still had activity. But so then Sasha, you know, in typical Sasha fashion, just thought about what's every sulfur compound we can possibly make and put every place on the ring. And he came up with some names like 2-tweedios and 5-tweedios. So he had this whole field of sulfur compounds. And he called me in the beginning before this got started. He said, Neil's got this young postdoc, Peyton Jacob, and this is his idea to make sulfur compounds. Are you going to make any more of these sulfur compounds? I said, no, I only was interested in the 4 sulfur. So it's okay if Neil goes ahead and does it. Yeah, obviously. Who's like, can we? Oh, we could make that. And then when Peyton joined the lab, of course, Peyton had more modern chemistry than Sasha had. So things like aero-bioaero couplings and things and lithium reagents. He brought all that. So then it opened up a whole new area of things that Sasha could make or they could make that would be different than what you could make with sort of some of the classical standard chemistry. So, oh yeah, well, we could put it, like you said, a selenium or tellurium there. Well, what effect would that have? So he was really, and people said, oh, he was a scientist. And I said, no, he wasn't really a scientist. He was an alchemist. He really was an alchemist. A scientist has a test, a hypothesis you test, and then you refine it, and you develop a theory and all. He didn't do that. He was really kind of an alchemist, a Renaissance alchemist.
Do you think that more research should be conducted that way without hypothesis-driven research? I mean, it seems like he discovered amazing things on just the basis of this sort of heuristic experimentation, seeing what happened.
Yeah, I guess, you know, if you think, well, some of the compounds in Bicalo and T-color compounds that I told him about, sent him to, but if you think about the fact that he was working in a fairly constrained chemical space, you know, the chemotypes are all phenethylamines of one stripe or another, or tryptamines. If you make 170 or 180 phenethylamines or a large number of tryptamines, you're going to find some interesting things there. And I don't know if you just started in some random field and started trying to do that. I mean, you probably wouldn't discover much. Today, I mean, we know enough about how they work. For example, they have to activate serotonin 2A receptors, and there are some animal models. You probably would get a good clue as to whether you had an active compound without testing them. Now, you know, when we used drug discrimination in LSD trained rats for most of the in vivo activity, and those were pretty reliable. Although they say you can get false positives, most of the things we got, if there was a known human data, we could show there was a good correlation. And I wrote a review on hallucinogens in 2004 where I think I put a graph in there that showed the correlation between drug discrimination activity and human activity. So you could do those things, but you know, whenever I talk about drug discrimination, I'll say, so if the rat responds on the LSD appropriate lever, the lever we've trained him with LSD on, all he's basically saying is, I think you gave me LSD. Well, that doesn't tell you anything at all. I think you really need to have human psychopharmacology to know what they do. Now, should people just do it like Sasha did, just take things and see what happens? I don't think that's a